Hello, this is conservation of momentum scenario number 2. The last scenario we looked at two different masses. One was stationary, the other was moving. But in this particular example, mass M1, a car of mass M1 or an object of mass M1 is actually moving at 10 meters per second. But the other mass is also moving, but it's moving at a lower speed of 5 meters per second. So eventually, this particular car catches up with M1, catches up with M2, hit it, got stuck together, and they start moving at the same velocity. Now, you will be required to be able to answer a question like this in the exam, and the first thing to do is to remember the law of conservation of momentum says total momentum before must be equal to total momentum after. So if you remember that, all you have to do is work out your total momentum before. So what would be the total momentum before is the product of mass and initial velocity for M1 and mass and initial velocity of M2. And if you put that here, we use small p to represent momentum. So momentum B4, that's just a short form for that, equals M1 U1 plus M2 U2. And then we can put the figures in, which is 10 kg multiplied by 10 meters per second plus 10 kg times 5 meters per second. So if we now put those figures together, that's going to be 100 plus 50, and that equals 150 kg meters per second. So the total momentum before is 150 kg meters per second. And that's our first equation. We then go on to what happens after collision when the two masses are now stuck together. They're now moving at the same velocity. So we now say the momentum after should be the product of the two mass, because they are now moving as one single body. We now say M1 plus M2 multiplied by V. That V we don't know. So we know M1 to be 10 kg plus 10 kg multiplied by V meters per second, which we don't know. So if we now look at that, that's going to be basically 20 times V. So we now have our equation number 2. According to the conservation of momentum, we must always go back to that. Okay? According to the conservation of momentum, P before must be equal to P after. It means momentum before must be equal to momentum after, and the momentum before here was 150 kilogram meters per second, and the momentum after here is 20 kilogram times V. V we don't know, so kilogram will cancel kilogram, okay, and then we can bring V here, and we can say that's 150 over 20 meters per second. You cancel that or use your calculator, that works out to be 7.5 meters per second. And that is how you do a question like that. So you can now write in words if you like, after collision, the two objects move at the same speed of 7.5 meters per second, the same direction. If you want to call it velocity, then you use direction. So obviously they are moving in the same direction. Okay? And that is how this question can be solved. Thank you.